All right, everybody, this is a guided walkthrough for the Buffer Overflow Zero Challenge from picoCTF from the picoCTF 2022 event. So this is a medium level challenge in the binary hacking category, and the description says, let's start off simple. Can you overflow the correct buffer? The program is available here, and there's a link. You can view source here, and there's another link. Additional details will be available after launching your challenge instance. So this is a challenge where you need to connect to the server in order to get the answer and complete the challenge. But we don't need to do that right now. The first thing we need to do is we need to download the 2 files that are associated with this challenge. So the first link is here. We can just hover over it, right click, and then select copy link. After we do that, we're going to go over to our web shell. And you know what? Let's make a directory to work inside of in here. So we're going to make a directory. Let's see. Let's call it buff0. So make directory buff0. Then we enter that directory. And then we're going to make sure that we're in this directory, and then we're going to download the file. So wget space, and then right click paste, and that will paste in the file address. So give that command, and then afterwards you should see the vuln file in your directory here. So we're also going to download the source code for this file. So we can give the same wget command as the first one, but we're just going to tack on a .c onto the end of this. So the first one is to .vuln. The second one is to vuln.c. Give that command, and you should have 2 files in your directory now. So before we can start messing around with this vuln binary here, we need to make it executable. You can make it executable with the chmod command. So chmod plus x vuln. And then afterwards, you're going to see that this is an executable file now. So we should have vuln and vuln.c in here. So vuln is the actual binary that we need to hack in order to get the answer. And vuln.c is the source code that was used to create this vuln file over here. So if we take a look at vuln.c, this is C code. So the binary was compiled using this C code here, and we'll talk a little bit more about what's in the C code in just a little bit. But for now, let's take a look at the presentation file. So this challenge is an introduction to binary hacking memory vulnerabilities. So memory vulnerabilities are flaws in a program which allow the contents of the program's memory to be modified in an unintentional manner. So some consequences of memory vulnerabilities can be seen here. So consequences of memory vulnerability: program crashes, program data leaks, program data corruption, and arbitrary code execution. So memory vulnerabilities are really serious. Of course, the vulnerabilities these days are a bit, they're usually not as easy to take advantage of as the ones that we see in CTF challenges like this. But the memory vulnerabilities, we need to learn the basics of these vulnerabilities before we can study binary hacking seriously. Okay, so the challenge goal for this particular exercise is something we like to call crash to win. So the code for this binary indicates that if the program crashes, then the contents of the flag.txt file will be revealed. So we got void sigseg v handler, and it prints out the flag, and then it flushes standard out, and then it exits. It makes use of this sigseg v handler by using this function here, signal zigzag v handler. But we're getting ahead of ourselves. Let's talk about what these kind of crashes are. So zigzag v refers to a segmentation violation, which is a program memory related crash. Segmentation violations happen when a program attempts to access invalid memory addresses. In this binary, it happens due to buffer overflow. So we're going to be talking about the type of vulnerability we're taking advantage of here. It's called buffer overflow, and it's a program memory vulnerability where users are able to overflow a program's memory buffer, which results in other parts of the program's memory to be overwritten. So for example, if you've got if you have a username here and for some reason you're able to overflow information from it, the information might end up in the address portion of the memory or in the phone number portion of the memory, etc., etc. So in this C code, the string variable is created with a set maximum size. So the user can send up to 99 characters and write it to this variable called buff1. However, the program also takes buff1, this variable, and copies its value to the buff2 array, which has a max size of 16 bytes. So if you take a look at the, let's take a look at vuln.c, and we see all the stuff that I was talking about over here. So the vulnerability lies over here. So the program asks for input, and it saves the input to the buff1 variable. So the buff1 variable has up to 100 bytes allocated to it, and the problem is that whatever you put into the buff1 variable with your user input, it gets copied over with the vuln function here. So the vuln function runs the string copy function, and it takes the input and it puts it in buff2, which is another array, but the buff2 array only has 16 bytes allocated to it, which means if there's more than 16 bytes inside of buff1 and it gets copied over to buff2, then there's going to be some overflow, and that's a big deal. Okay, let's talk a little bit more about this. So we're talking about some buffer overflow, and the reason why buffer overflow can occur in this binary is because it's coded with memory unsafe functions, specifically string copy, which does not validate the size of strings. So these are vulnerable C functions. So there's the get C function, which is used to read a line of user input. This one is unsafe, but the more important one in this exercise is the string copy function. So it copies a string from one location to another, and the string copy function doesn't check to see if whatever you're sending over to the target location is smaller than the maximum size of the location you're copying it to. So if we send more than 16 bytes to the user input, it'll be copied into the buff1 buffer, with excess input overflowing into other memory addresses. So we got buff1, this is what we put in as user input. If afterwards it gets copied over to buff2, but if buff2 gets overflowed, the rest of the input will end up in other memory addresses. And this is where the crash happens. So this will crash the program due to segmentation violation, and this binary is programmed to output the flag in that case. So let's go over to the web shell. Okay, so for this challenge in particular, we need to create a flag file to access. So we're just going to echo out something and create a flag file, because that's what we need to access to prove that we got access to the flag. We got the flag HackerFrogs rule. Okay, so if we get this message by If we get this message by hacking the binary, then we know that we've finished the challenge. Okay, so we're just going to run the vuln binary here, just like this. Okay, input. So we know that we have to send input in excess of 16 characters. So we can count 2, 3, 4. So that's 10, 6. So that's 16 characters. So if we send 17 characters, it just says that the program will exit now. That's because we haven't overflowed a complete memory address. So a complete memory address is usually 8 characters. So we're just going to overflow by in excess of 8 characters. So we're just going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10. So that's 16. And we're just going to add another 8. 1, 2, 3, 4, 5, 6, 7, 8. And then that overflows the buffer. That crashes the program, and we get the flag over here. So we got the flag for HackerFrogs rule. Okay, so what we need to do is we need to recreate this with the binary that's running on the server, and this is how we access it. So buffer overflow. This is the challenge. We need to launch the challenge instance here. After a few seconds, we're going to see that we can connect using this command here. So if you want to try this out yourself, you can try using netcat. But if you're trying to complete the challenge, I recommend you use your own netcat command because the port number is going to be individualized to your user account. If you use my port to access the program, you're going to get my flag, and my flag doesn't work for you. Anyways, okay, copy that. Then we run the netcat command to access the binary on the server. Input. So we're just going to give the same input here that we did for the offline binary. And we see here we got picoCTF overflows aren't that bad, and then and then the personalized portion. So I'm just going to copy this all. And then I'm going to go over to the challenge and paste in the flag. Okay, so before we finish the challenge, let me demonstrate over here what exactly is going on. So if we do, I'm going to use a program called Radare2 to debug this binary. Radare2 debug vuln. Okay, and then I'm going to analyze the binary. Okay, so after we do that, I'm going to print out the main function of the binary here. So print disassembly function at main. This is going to get us assembly instructions for the main function. So the main function is going to copy our user input. It's going to take our user input. So the gets function in C is what takes user input. And we see right before it calls the gets function, it's gonna load in a specific memory address. So the memory address in this case is called var74 hex. And what we can do is we can load in, we can examine this part of the memory. The binary runs this C function over here called gets, and gets is going to take in user input, and then you're going to be able to put something into the binary using keyboard input. And whatever is taken in is going to be saved over to this memory location, var74h. So what we're going to do is we're going to run the binary. So DC inside of Radare2 runs the binary. It'll ask for input here. We'll put in 16 bytes, and then we'll add another 8 bytes. Okay, and then we see that there's a crash. So the crash happens here, and what we can do is we can take a look at what's in var74h. So var74h is going to be located at EBP minus 0x74. Okay, so this is where our input ends up. So it ends up over here. So it ends up over here. This is the buff1. This is the buff1 variable over here. So we put it in here. It also gets copied over to buff2, and this is where buff2 is. So it's slightly behind the other variable. So this is buff1, this is buff2 over here. So we see buff2 gets filled up, and then it gets copied over to other memory addresses. And because you've put illegal information inside of other memory addresses, the program crashes. And we know from the code that when the program crashes, it gives you the flag. Okay, so let's go ahead and get out of here. All right, so we've got the flag here. We submit the flag, and then we're done. Everybody, that was a guided walkthrough for the Buffer Overflow 0 challenge from picoCTF.org as part of the picoCTF 2022 event. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out!
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.